Hello everyone. In this talk, I will present a framework for the automated development of hybrid graphical textual modeling editors. And this framework has been developed at the University of York. For the agenda, I will first present what hybrid modeling editors are, and then I will present some examples of hybrid modeling editors. I will then show the framework called Graphite, and finally, I will show the generation workflow for such hybrid editors. To understand what hybrid modeling editors are, you would have to understand what hybrid graphical textual DSLs are. First, a domain-specific language, unlike a general-purpose language, can solve problems for any field, for any domain, but it is tailored only for that domain specifically. And a hybrid graphical textual domain-specific language has a part graphical and a part textual syntax, meaning that some parts of the syntax are graphical, whereas others are textual. However, generally, they are predominantly graphical, but they contain some embedded textual notations to define complex expressions and behavior. And here on the left side, we have an example of such a hybrid DSL. This is a simple state machine language in which the states and transitions are modeled graphically, but the guards are expressed textually using textual expressions. And the nice thing about this is that the textual expressions can be written using syntax-aware editing features, code completion, syntax highlighting, and so on and so forth. Here I present an example language that will be used throughout the presentation. Now I present the abstract and concrete syntaxes. I assume most of you are familiar with language engineering. An abstract syntax covers the concepts of the language, the relationships between the concepts, independent of any representation, whereas the concrete syntax is actually what the user uses and sees. And here I am presenting the meta model of a project scheduling DSL. It's used for modeling project plans. And the main concept of this language is a project. A project has a number of tasks and a number of people. A task has a name. It has a number of efforts, a leader, and a list of dependencies. A person has a name, and an effort is allocated to a person, and it has a number of months. Now, for this particular example, we will assume that stakeholders would prefer to have a hybrid notation. Specifically, they would like to have the tasks and the people represented graphically using these graphical representations. However, they would like the efforts to be represented textually because it may often be difficult to represent in a diagram a large number of efforts. And in this case, the textual notation takes the form of key-value pairs in which the key is the person and the month is the value. And here we have a concrete example of an effort expression. We have 3 efforts, one on each line. The first effort is allocated to the person Alice, and it has a number of 3 months. Now, ideally, such hybrid editors should provide these capabilities. And on the left side, we have the minimum components that such a hybrid editor should ideally provide. First, it should have a diagram in which you can view the graphical part of a model. And in this case, on the left side, we have 3 views. The minimum views that this editor should have are a palette from which you can drag and drop various graphical representations onto the diagram, and this instantiates various types of model elements. Then a properties view in which you can view and edit the properties of the model elements. And notice here that there's a textual editor for the efforts. This is not a plain textual editor. This is a smart textual editor. Unlike the name. For the name, there's another textual editor, but that would be a plain textual editor. And finally, a problems view in which one can view any errors or any inconsistencies reported from the model. And the capabilities of such hybrid editors are, first, smart textual editors. I've already showed this. So this is not a plain textual editor. It has syntax-aware editing feature, code completion, syntax highlighting, error detection, and so on and so forth. Then textual graphical cross-referencing. Since we have some parts of the model represented textually, other parts represented graphically, to be able to have complex behavior, you may often need to have references between the graphical and the textual parts. So in this case, the textual expression indeed has references. It has references to Alice, Bob, and Charlie. So you can't write any person's name. It has to be a person that actually exists in the graphical part. Then another feature that would be nice to have is consistency enforcement. As the model evolves, it would be ideal to enforce consistency between the graphical and textual parts. Let's assume we have this example and somebody renames Bob in the diagram to Robert. Well, one option would be to not update the textual expression, but you may have hundreds of such textual expressions that currently have a reference to Bob. But now you would have an inconsistency because Bob has the name Robert in the diagram, but there are hundreds of textual expressions that still reference Bob. So ideally, you should update all those textual expressions with the new reference. Then another nice feature would be uniform error reporting. If there's any error in the model, for example, if the textual expression cannot be parsed successfully, for instance, instead of 3, you would write 3x, which cannot be parsed. It's not an integer. That should ideally be reported in the problems view. Integrated refactoring. This would be the capability of doing refactoring directly from the Smart Textual Editor. Somebody could go in the Smart Textual Editor, select Alice in the textual expression, then right-clicking and choosing the option to do integrated rename refactoring. Then refactoring would be performed consistently across the entire model, even if you have hundreds of textual expressions. And two other features would be tolerance of temporary inconsistencies and integrated abstract syntax graph. I will not go into them in this presentation, but you can ask at the end of the presentation if you're interested about these capabilities. Now I show some actual concrete examples of hybrid editors to see how they look like in practice. The first one, this is for the project scheduling DSL, the one that I've already presented the abstract syntax of. Here we have a number of tasks, a number of persons. You can see an auto-completion menu in the Smart Textual Editor. At the bottom, this is a DSL for modeling the testing space of robotic systems in simulation. It defines various fuzzing operations with a graphical representation, and the textual representation specifies when the fuzzing operations should be activated. There are some conditions, and depending when the conditions hold, the fuzzing operations get activated and deactivated. On the right side, here we have another hybrid editor. This is called the Structurizer DSL. It mimics the official Structurizer language. If you're familiar with Structurizer, it's a software architecture modeling language with which one can define various architectural viewpoints at various levels of abstraction. For instance, at the container level, at the component level. And here we have a tree editor which has a graphical representation and also some smart editors for inclusion and exclusion expressions. In Structurizer, you can specify what should be included in those views or should be excluded from those views. And here we have two other hybrid editors. Here on the left side, we have a DSL for modeling cloud services and infrastructure components for the software company NetApp. And we have various cloud services defined in the diagram. And you could also see that there's a problems view because there are some errors in the textual expressions. Currently, CVO2 is referencing volume 4, but CVO2 doesn't contain any volume 4. It only contains volume 1, 2, and 3. And so you would get an error marker. The error marker will be shown here, but also in the problems view. On the right side, we have another DSL, and this is called the Flow Designer DSL. This is often used by Obeo in their samples, and this has been extended with a textual notation. At the bottom, you could see some routing rules that benefit from syntax-aware editing features. And these rules specify how information should flow throughout this system. Now I will show a demo. This is the Cloud Services DSL that I just presented. At the bottom, we have a textual expression for defining volumes. I show the auto-completion menu. Now I show a different textual expression. So you could have multiple notations in the same DSL. This is the Flow Designer DSL. At the bottom, we have a routing rule. And now I attempt to write a new routing rule. I mainly use the auto-completion menu to write this rule. Now I show the Structurizer DSL. Here we have the definition of the C4 model. In Structurizer, you have a C4 model in which you define your various components. And here we have a system context view diagram, and you can open it directly from here. So that opens this view, and the textual expression is star, meaning that everything from the C4 model is included at this level of abstraction. Now if I remove the textual expression, everything would be removed from the diagram. Now I show that you can't use only star. You could do filtering by elements, by relationships. Now I show what the container view looks like. Here we have a textual expression that does filtering by tag. And from this editor, I open the diagram of this view. And here, filtering is done using this condition. It includes all elements that don't have the tag person optional. In this case, the person Bob, it was excluded from the diagram. So there's only Alice, but now if I change it to person main, Alice would be removed and then Bob would be shown. So in a way, now I showed the semantics of the language, not just the syntax. This is the fuzzing-based testing DSL. Here we have the testing space of robotic systems in simulation. We have various tests defined. And from that diagram, I open a different diagram. And here we have the results of executing this fuzzing operation. And to activate the fuzzing operation, this condition is used, which is shown in the Smart Textual Editor. Now I go back to the first diagram. And from it, I open a different diagram. So here I'm just showing that it doesn't have to be one diagram. You could have multiple diagrams, and you can have multiple textual notations. Now, this is the project scheduling DSL, the one that I've shown as an example in the presentation. And here we have 3 tasks: analysis, design, and implementation, Alice, Bob, and Charlie. And we have some relationships between them, some dependencies between them shown by the edges. And the first task, analysis, has 2 efforts, one referencing Alice, another referencing Bob. Then I will go into the second task, and here there are no efforts. And in the implementation task, we have 3 efforts referencing Alice, Bob, and Charlie. Now I will show some of the features that I've just presented. Smart Textual Editors. Well, this is the Smart Textual Editor shown here. And you could use auto-completion. You would have error detection if you write something that is syntactically incorrect. Now, another feature would be textual graphical cross-referencing. Now, I'm referencing the persons Alice and Bob. They exist in the diagram. Technically, you could write any name, but you would get an error. So from the textual expressions, you can reference elements defined in the diagram. And you could also navigate to them. So from a reference, from the textual expression, you could directly navigate to the diagram in series. Now for error reporting, if you write something that is syntactically incorrect or semantically incorrect, you would get an error marker shown here. You would see the exact error. And additionally, you would also see it in the problems view. Now, going back to the textual expression, you would remove that, and of course, the problem would disappear from the problems view. Now, another feature would be integrated refactoring, doing refactoring directly from the textual expression. You would right-click a reference from the textual expression, you'd rename element, a pop-up window would be shown, and then you enter the new name. Well, it would be renamed in the diagram, of course, but also in all textual expressions that were previously referencing Bob. Now they instead reference Robert. Now, a final feature would be consistency enforcement, going directly in the diagram and renaming Robert into Bob. This, of course, will update all affected textual expressions. And even if you delete Bob, this change would be reflected in the textual expressions. Well, the challenge in doing all of this is doing it efficiently, because you may have hundreds of such textual expressions that reference these model elements. Now I start presenting the framework. It's called Graphite. It has been developed in academia. It's open source, and it takes the form of an Eclipse plugin. It is based on EMF, Series, and Xtext. I assume most of you are familiar with the Eclipse modeling framework. It is the modeling framework used by Eclipse to define models, meta-models, whereas Series and Xtext, they are state-of-the-art graphical and textual modeling frameworks. You can define graphical DSLs, textual DSLs, and you do need domain knowledge of EMF as well when using Series and Xtext. And it is available here in this GitHub repo. And by using Graphite, one could develop such hybrid editors almost automatically by using automatic code generation. But you would need some handwritten code, minimal handwritten code, and some configurations. Of course, you would have to define yourself the abstract syntax, meaning the meta model, the graphical syntax with Series, and the textual syntax with Xtext. This shows it at a high level what would have to be defined. Here we have the hybrid editor. On the left side, I'm showing that you would have to define a Series viewpoint specification model. It is a serious way to define the graphical syntax for a specific meta model. It would associate various parts of the meta model with a graphical representation. In this case, it would associate a person node and a task node with some images, person PNG and task PNG. Whereas on the right side, I am showing that you would have to define an Xtext grammar to specify to what notation this expression should conform to. And the grammar, of course, references the meta model. Now, I will present at a high level the generation workflow for such hybrid editors. This is the diagram for the entire workflow. I will not go into it in the details, but if you're interested, you can ask questions. What is important is on the right side. First, you would define the meta model. Well, I already presented this. You would define the various concepts of your domain, what concepts you would like the language to have. Now, once you've defined the meta model, you would have to decide what parts of the language should be expressed graphically and what parts of the language should be expressed textually. And in our specific example, I said that in this case, stakeholders would like to have the efforts modeled textually. So considering only the textual side, you would have to add string attributes and annotations to the meta model for every property that you would like to be expressed textually. In this case, we have just one property, the efforts list. So for that, you would add one string attribute to the meta model and one annotation. This is not ideal. It makes the meta model a bit larger, and in some cases, you may not be allowed to modify the meta model. So this is a limitation of this tool. Then you would have to modify a bit the generator model. If you've used EMF, you should have an idea of what the generator model is. It can be generated by using Eclipse's tooling. From a meta model, once you have a meta model, you can generate a generator model. However, it has some default settings that have to be changed. Specifically, one property has to be changed because by default, the generator model has a default eObject implementation. The default eObject impl class provided by EMF. Well, with Graphite, you cannot use that. You have to specify a custom eObject implementation. And this class is already provided by Graphite. you just have to set the property that specifies the value of this class. Once you've done that, you can launch the EMF code generator, and then this would generate 3 projects. They are Java projects. They contain the model code, the edit code, and the editor code. They contain Java code, and they define the modeling infrastructure that enables EMF modeling. Once you've done that, you can start doing the manual part. This is the largest part that you would have to do in this entire process, the concrete syntax definition. And for defining the concrete syntax, you would need domain knowledge of Eclipse Serious and Eclipse Xtext, which even if you have domain knowledge, it's not such an easy thing to do. So it takes quite an effort to define the graphical syntax and the textual syntax. And in Serious, a graphical syntax is defined using a Serious VSM, or a Serious Viewpoint Specification Model. I mentioned this before. You would declaratively associate various parts of the abstract syntax with some graphical representations. Then for the textual syntax, you would have to define some grammars, and that may not be such an easy thing to do. And in the grammar, you specify how the textual expression should look like, and you have to specify what model elements should be instantiated as you're typing textual expressions. So behind the scenes, you are writing textual expressions, but actually model elements are derived, and you could access them in model management transformations. So if you would pass the model as input to a model transformation, it will not see just the string, not just the textual expression, for instance, the effort. It will actually see the list of effort model elements that can be iterated. You could do for statements, if statements over them. So you don't have to parse again those textual expressions in model management operations. You could directly access those underlying model elements. So it doesn't just see them as text, but it sees them as a graph, as concrete model elements. Now, the final step would be to launch Graphite's generator. And you would just click a button. Now I've showed the process for doing this. The output would be a list of classes generated by Graphite, but also a list of modified classes. Specifically, Graphite would modify some classes generated by EMF in this step, launching the EMF code generator. And what I want to highlight is that technically you could implement everything yourself. You could develop such editors with handwritten code. So you would write manually the code for such editors that provide all of these capabilities. However, this is a significant effort, and it may take a large amount of handwritten code, and the handwritten code may differ for every DSL. And you would have to do this for every DSL. Now, with Graphite, this entire process is streamlined. It should generally work for every DSL in theory, but of course, there may be some examples of DSLs for which this may not work. For instance, you don't want to modify the meta model. Well, in this approach, you actually have to modify the meta model a bit. You have to add some string attributes and some textual expressions. And here I show at a high level the manual effort involved in doing this. You define the meta model. You've decided what parts are represented graphically and textually. Now, in blue, I show the graphical syntax. We have the Serious VSM. And for our example, I said that a person and a task should be represented graphically. And then for the textual syntax, you would decide that the efforts are represented textually. And in your grammar, you have to reference the meta model. And you have to instantiate effort model elements. As you're parsing the textual expressions, you would be deriving efforts behind the scenes. So this is the most difficult part in the entire process, because even if you have serious domain knowledge and XX domain knowledge, it can fail. So this can be made invalid in various ways. You have to ensure that you're representing different things, and you have to ensure that what you're referencing from the grammar, for instance, the person, this is a person element, well, this is represented graphically in the series VSM because you defined a person node. This is just to ensure textual graphical cross-referencing, because if you don't do this, you wouldn't have references between the graphical and textual parts of the model. Now, another question would be, how do you make sure that it actually supports references between the graphical and the textual? Well, further validation can be performed to check that for whatever you're referencing in the grammar, you're defining in the graphical syntax. Now, it must be done manually, but by using model transformations, this can be further extended to make it automatic. Regarding the meta model, I said that the meta model must be modified, and here I'm showing what exactly would have to be modified for the meta model. You would define the meta model, and then you would decide which parts are represented textually. After doing that, for each property that is expressed with a textual syntax, for instance, in this case, just the efforts, you would add a corresponding string attribute and an annotation. And in this case, I show an example. We have the efforts property, and I've added the efforts expression string. And the efforts expression string stores the textual representation of the efforts, and they are bidirectionally synchronized. So as you do a change in one of them, it is automatically reflected in the other property. But there is support for some temporary inconsistencies. I've mentioned this earlier. Now, what does the annotation define? It links the added string attribute with the property that it represents, so the efforts list, with the grammar that it must conform to, and with the entry rule used by the grammar. What would happen? When the efforts expression is modified, it would be parsed according to this grammar. By using this entry rule, you could use different entry rules for your specific properties, and the result would be a list of model elements, so a graph, an AST, actually a graph in this case. And the output would be assigned to the derived property, in this case would be the efforts. So as you're setting the efforts expression, the efforts would be set after you modify the efforts, well, the efforts expression would be modified. So most of the time they are bidirectionally synchronized, but it allows temporary inconsistencies. This is how you would trigger the process after you've defined the meta model, the generator model, the series VSM, and the XS grammar. You would select all four of them. In this case, this is the Equer meta model, the generator model, and the O-design file is the series viewpoint specification model. You would select them. You would right-click in the Eclipse workspace. You would see here Graphite, and you would select Generate Hybrid Editor. This would generate all the code required to develop the hybrid editor that I've shown with the capabilities that I've shown for this particular DSL. So if you'd have a different meta model, a different graphical syntax, a different textual syntax, it should work for any DSL in theory, but more testing is necessary. And also there are other facilities provided by Graphite, for instance, validating the grammar, validating the meta model, and generating grammars. One of the largest efforts is the definition of the grammar, because not many are experts in Xtext. Well, the capability of generating a grammar simplifies a bit this process because it provides a starting point. So from the meta model, considering the structure of the meta model, considering the annotations, it would generate a grammar that is compliant with Graphite, because the grammar cannot look in any way. It has to be defined in a specific manner when using Graphite. Now, that's just a starting point. It's just a skeleton. You can modify it according to your needs. Then it also provides the capability of validating the grammar, because considering the grammar must look in a specific way, it would be nice to be able to know that it actually works with Graphite, and to validate the meta model. Now, what's next? Two other features that would be nice would be integrated search and find all references, to be able to do search and finding references across the graphical and textual parts of the model. So selecting something, then finding all reference from that, seeing whether it's defined graphically or textually, because you may have hundreds of textual expressions, and you may not know where a specific model element is referenced unless you actually go into the XMI format of the model. You do a Control F, you do a search, and you would see all the textual expressions manually. Well, with these facilities, you would see all of that automatically. Now, going forward, it would be very nice to develop a similar framework, but for the web. Right now, this is tailored for the desktop, and it doesn't have a language server protocol, a graphical language server protocol. Ideally, this should be extended for Serious Web or Eclipse GLSP or something very similar, and by using something else other than Xtext, like Langium. And so you would have a language server protocol for the textual part and a graphical language server protocol for the graphical part. And considering that the biggest engineering effort is in the definition of the concrete syntaxes, the serious VSM, the Xtext grammars, and even the meta model if you don't have EMF expertise, it would be nice to integrate large language models. And in this way, users with minimal expertise in Xtext, Serious, and EMF would be able to use some high-level prompts to generate the syntax. The user would just define using text, using a prompt, and by providing an image, what the Serious VSM should contain and what the grammar should look like. And one note, the current work, this is obvious now, but the work doesn't use any LLMs right now. So all of the code that is generated is not based on EMF. It's based on model-driven engineering techniques, models, meta-models. You pass models as input to model and model-to-text transformations that generate all the code automatically. The difference is that it's deterministic. With LLMs, they are probabilistic, and you cannot ensure that they work reliably. And it's open source. You are welcome to contribute if you're interested. You can use it in its current form. So it should work. It should provide the features that I've shown earlier. But if you're interested, you can easily extend it. So it's very easy to extend Graphite. And if you're interested, it would be nice to contribute. Then the GitHub repo is shown here. And that was about it from me. Thank you very much.